Hey everyone, in this demo, I'll show how a pen tester detects an ICMP flood or ping DoS attack using Wireshark. We'll first generate a baseline of a normal ICMP traffic, then simulate a flood using nping on Windows, and finally analyze it in Wireshark using protocol hierarchy, conversation, and IO graphs to clearly spot the anomaly. Now comes the question, what exactly is ICMP? ICMP stands for Internet Control Message Protocol. It's mainly used by ping command to check if a system is reachable. Normal ICMP traffic is very small in volume, just a few packets exchanged during connectivity tests. If we see thousands or millions of ICMP packets, that strongly indicates a ping flood attack. Now, let's build a baseline by sending a small controlled set of pings to safe documentation IP address. I'll start by opening the command prompt and entering a command ping -n 5 and a safe documentation IP, that is 192.0.2.20. Now, before hitting on enter, I'll just explain what exactly this command do. Ping is Windows utility for ICMP echo request. -n5 sends exactly 5 packets, and this IP address reserved for testing and documentation. Now, I'll go back to Wireshark, click on Wi-Fi, and as you can see, the packets are being shown on the screen, which are, you can say, network traffic. Now I'll go back to command prompt and hit enter. As you can see, it had started pinging this IP address. Now I'll go back to Wireshark and show you the ICMP echo ping request and echo ping reply. As you can see, this is the ICMP echo ping request and ICMP echo ping reply. There will be total 5 packets of ICMP. Then, to simulate a flood using nping, which comes with nmax and works on Windows, I'll go back to a new command prompt window, type a command nping -ICMP -rate 100 -count 1000, and the same IP address which I used previously. Now, before hitting on enter, I'll just explain what exactly this command means. nping is a packet generator tool from nmap. ICMP sends ICMP sends ICMP echo request -100 packets per second, and count 1000, total 1000 packets. And this is the target IP which I used previously. Now I'll hit on enter. This is much faster than normal ping activity and simulates a ping flood DoS in a controlled way. Now, I'll go back to Wireshark. I'll apply ICMP as the display filter, and here you can see ICMP echo request and reply. I'll go to statistics, protocol hierarchy. Protocol hierarchy breaks down the traffic by protocol type and shows the percentage of total packets. Here, ICMP is using 100% of traffic. That's abnormal because in real network, you usually see a mix of protocols. Seeing only ICMP at such volume is a clear red flag. Now, I'll go back to Wireshark screen again. Click on statistics, conversations. Conversations view shows the communication between IP pairs, including packet counts, byte transferred, and duration. In our case, it shows massive packets count between our system and between this particular IP address which we used while pinging, and in the nping, it has sent over 1005 packets. This confirms it's not just a few pings but thousands of ICMP packets exchanged. Now I'll go back again on the Wireshark screen, click on statistics and IO graphs. As you can see, first let me explain what exactly is IOgraph. IOgraph displays traffic volume over time, usually packets per second. In a normal ping test, the graph is flat and minimal. During the flood, the graph spikes sharply, showing a very high packet rate per second. This visual pattern makes it easy to identify the attack.